All right, so on the warm-up today, we wanted to name alternate exterior angles. Who can give me a pair of alternate exterior angles? I heard 2 and which one? 2 and 8, and 1 and 7. Angle 2 and angle 8, angle 1 and angle 7. That alternate part means opposite sides of the transversal. And the exterior part means not in between the two lines. What's the relationship between our alternate exterior angles? Are they complementary, supplementary, or congruent? Look at them carefully before you answer. They are not supplementary. They are congruent. Let's talk about why. So yesterday, we recalled that alternate interior angles were congruent. So angles like 4 and 6 would be congruent because they're alternate interior angles. We established that yesterday along with y. I want you to look at angles 2 and 4. What's the special name that we have for angles 2 and 4? They're vertical angles, and vertical angles are congruent. So 2, 4, and 6 are all the same size. What's the vertical angle for angle 6? Angle 8. So 6 and 8 would have to be the same size. That means that angle 2 and angle 8 have to be the same size. That's why my alternate exterior angles are congruent. All right, number 4, they call these same side interior angles. When we studied this, we called them consecutive interior angles. It means the exact same thing, and you can see them referred to either way. Give me some same side or consecutive interior angles. What would be a pair of consecutive interior angles or same side? 3 and 6. So angle 3 and angle 6. What's another pair of consecutive same size interior angles? Angle 4 and angle 5. Come over here and look at those. Let's look at like 3 and 6. Do those two look like they're the same size? Do they look congruent? For 3 and 6? Those don't look the same size. Like 2 and 6 look the same size, but 3 and 6 don't. So they're not congruent. They are supplementary. We shouldn't just rely on what they look like, so let's go back and talk about how I know for sure, not just what does it look like is going on here. Do you remember how we said 2 and 6 were the same size? That was from yesterday because they're corresponding angles. What do we call the angle pair for 2 and 3? It's a linear pair. And a linear pair adds up to how much? 180. So a linear pair is supplementary. Well, angle 6 is the same size as angle 2, so I could replace angle 2 with angle 6, and it's still going to add up to 180, so it's still going to be supplementary using our substitution property there. All right, I need you guys to go ahead and pull out your books. We're going to open them up to page 374. 374. We're going to talk about an exterior angle inequality theorem. We're going to talk about relationships that occur inside a single triangle and inequalities that I can write about one triangle. Before we talk about the exterior angles inequality theorem. Let's see if we can remember the exterior angles theorem. So I'm going to name these angles here. I'm going to call this angle A, angle B, and angle C. Call this one down here angle D. So that way I've got all my angles labeled. Is angle A over here an interior angle or an exterior angle? Inside or outside? Exterior. Does anybody remember what we would call these two angles? B and C. In relationship to angle A, what would we call angles B and C? First of all, are they interior or exterior angles? They're interior because they're inside that triangle. Are they touching angle A? What was the word that we use when you have to go across the triangle to use it? Thinking of a word that starts with R. You tend to use one of these at home with your television. These are remote interior angles. Does anybody remember what the relationship is between the exterior angle and the two remote interior angles? Yeah, the sum of the two remote interior angles is equal to the measurement of the exterior angle. So the measurement of angle A is equal to the measurements of angle B plus C. So this we've studied already. We've talked about this. The exterior angles inequality theorem, and this guy in this box up here is way up at the top of the page. It's almost like undetectable up at that almost top margin on page 374. What this says is that if I have to add these two angles together, B and C, to get angle A, that means angle A is bigger than angle B. That means angle A is bigger than angle C, because I have to add B and C together to get something that's the same size as angle A. So exterior angles inequality theorem says the measurement of angle A is bigger than the measurement of angle B. Measurement of angle A is bigger than the measurement of angle C. It would have to be bigger because if I take this away, that's not equal anymore. I have to add B and C together to get A. So if I take away one of these pieces, now this side is too small. They're not equal anymore. So I want to draw a picture and practice a little bit more with this before we look at the example problem in your book. So I want you to add this picture in. So I'm going to call this A, B, C, D, E, and F. Is angle A over here an interior angle or an exterior angle? Exterior. It would have to be bigger than the two remote interior angles. What are the remote interior angles for angle A? E and F. So the measurement of angle A is greater than the measurement of angle E. The measurement of angle A is greater than the measurement of angle F. Are there any other exterior angles? Yes. Name me one of them. C. So here's an exterior angle. What are the remote interior angles for C? D and E. Measurement of angle C is greater than the measurement of angle E. The measurement of angle C is greater than the measurement of angle D. The exterior angle is bigger than either one of the two remote interior angles. Are there any other exterior angles here? Which one? B. Angle B is an exterior angle. What are the two remote interior angles for angle B? D and F. So the measurement of angle B is greater than the measurement of angle D. The measurement of angle B is bigger than the measurement of angle F. The exterior angle is always going to be bigger than either one of those two remote interior angles. And if you look up at the top of page 374, that's exactly what my exterior angles inequality theorem says. It says the measure of an exterior angle is greater than either of its remote interior angles. It's bigger than either one of them. Not both of them together, but it's bigger than one, and it's also bigger than the other one. So far, so good? All right. I want to look at example number 1 that's in your book now that we kind of know what that inequalities theorem is saying. So example number 1 in the book has this picture right here. And the first thing they're asking me to find is this. You guys remember your alligator rules from elementary school with your inequalities? Alligator always eats what? The bigger number, the bigger thing, right? Which thing is the alligator eating here? Which piece is the alligator eating? Measurement of angle 1. So I want the measurement of angle 1 to be bigger than whatever it is that I'm looking for. So I'm going to change this into words here. I want to find angles smaller than angle 1. Angle 1 has to be the bigger thing. Is angle 1 an interior angle or an exterior angle? It's exterior. It's right here. So I'm going to look at the triangle that it's an exterior angle for. That's going to be triangle PQR. Because while I have this weird little triangle over here, angle 1 does not touch that little triangle. To be an exterior angle, it has to be right up next to it. It has to be touching that triangle. That's what makes it an exterior angle there. The remote interior angles that go with angle 1, well, that would be those two put together, right? Because that makes the angle in this corner. The other remote interior angle would be these two put together, because again, that makes the angle in this corner. So these are my remote interior angles. So we just said that our exterior angle is bigger than either one of those remote interior angles. So the measurement of angle 1 is greater than this remote interior angle up here. That's angles 3 and 4 put together, right? So it's bigger than the measurement of angle 3 plus the measurement of angle 4. There's another remote interior angle, and it's made up of these two angles put together. So that means that angle 1 is bigger than what? Yes, measure of angle 5 plus the measure of angle 6. They asked me to find the angles that angle 1 was bigger than. Well, it's bigger than angle 3 and 4 put together. So is angle 1 bigger than angle 3? Is it bigger than angle 4? It's bigger than angle 5 and 6 put together. So is it bigger than angle 5? Is it bigger than angle 6? All right, so my full and complete answer. Measurement of angle 1 is greater than and now I'm going to list them all out here. It's bigger than the measurement of angle 3 plus the measurement of angle 4, because that does make an angle up here. It's bigger than angle 3 by itself. It's bigger than angle 4 by itself. It's bigger than angle 5 plus angle 6, which means it has to be bigger than angle 5 by itself. And it has to be bigger than angle 6 by itself. So that would be my full answer for part A. Measurement of angle 1 is bigger than angles 3 plus 4, then angle 3, then angle 4, then angle 5 plus 6. It's bigger than angle 5, and it's bigger than angle 6. That is everything that I can prove angle 1 is bigger than. When I'm doing these questions, I'm not looking for which ones look like they're smaller than angle 1. It has to be things that I can prove are smaller than angle 1, which is why I have to use my exterior angles inequality theorem. So just because it looks smaller isn't enough. All right, let's do part B. First of all, help me interpret what this says right here. Alligator is supposed to be eating the bigger thing. Which piece of that is the alligator eating? It's eating measures, right? It's not eating the measure of angle 8. So am I finding angles that are bigger than or smaller than angle 8? Bigger. Find angles bigger than the measure of angle 8. So I want to think about my exterior angles inequality theorem. The exterior angle is always bigger than the two remote interior angles by themselves. So let's come over here and look at angle 8. Is angle 8 an interior angle or an exterior angle? Interior, because it's inside my orange triangle, right? Well, I would need an angle that is outside the triangle, an exterior angle, to say that it's bigger than angle 8. I can't do the one that it's touching, though, because even though on this picture it looks like angle 1 is bigger, I could draw another picture that has angle 1 right here and angle 8 right here, where 1 is smaller than 8. It all depends on my picture. So I have to find an angle that this is a remote interior angle for. And you said that's angle which one? 2. Angle 2. This is an exterior angle. And angle 8 And then angle 5 plus 6 would be my remote interior angles. So the measurement of angle 2 is greater than the measurement of angle 8. Let's see if we can do the check down at the bottom. Same kind of idea, same kind of thing. There's a couple triangles in the picture in the check, though. First of all, let's figure out what we're supposed to be looking for. Am I looking for angles that are bigger or smaller than angle 1? Smaller. Find angles smaller than the measure of angle 1. Well, where's angle 1? Is it interior or exterior? Exterior. Here's angle 1. Angle 1 is an exterior angle for 2 different triangles in this picture. Let's draw around both of them so that we can see them. Here's one of the ones that I'm seeing. So there's one triangle that it is an exterior angle for, because again, it's touching that triangle. It's touching that blue triangle on the side over there. It's also an exterior angle for this triangle, for the red one, because it touches the side of the red triangle, right? So I got to look at both of these if I'm going to find angles that are smaller than the measurement of angle 1. Let's look at just the blue triangle first, so the smaller one of those 2 triangles. What are the remote interior angles for angle 1 that are inside the blue triangle? 4 and 6. So the measurement of angle 1 is bigger than the measurement of angle 4. Measurement of angle 1 is bigger than the measurement of angle 6. So far, so good? Let's look at the red one now. What are the remote interior angles in the red triangle? 3 and 4 together, right? Because that makes up this top vertex, this top angle. What's the other remote interior angle? 7. So the measurement of angle 1 is greater than the measurement of angles 3 plus 4. Measurement of angle 1 is greater than the measurement of angle 7. Let's take that and write it as one complete answer. Measurement of angle 1 is greater than we know it's bigger than the measurement of angle 4. We know it's bigger than angle 6. I know it's bigger than angles 3 plus 4. If it's bigger than angle 3 plus 4, I already said it's bigger than angle 4. It would also have to be bigger than which one? Than 3. Measurement of angle 3, and it's bigger than the measurement of angle 7. It's bigger than all of those. All right, last piece. What do they want me to find down here? I want angles that are bigger or smaller than 7? Bigger. Find angles bigger than the measurement of angle 7. Well, angle 7 is right here. It takes exterior angles to be bigger than an interior angle, right? I need exterior angles that this is a remote interior angle for. So look at that big red triangle. What are some exterior angles on the big red triangle? 2 and 1, right? Those are outside the big red triangle. So the measure of angle 2 is greater than the measure of angle 7. Measure of angle 1 is bigger than the measure of angle 7. I see 2 more. I want you to look at this light blue triangle right here. What would be exterior angles of that light blue triangle? 4 and 6. So it's also bigger than angle 4, or sorry, smaller than angle 4 and smaller than angle 6. So my full and complete answer is that the measure of angle 7 is smaller than measure of angle 1, measure of angle 2, measure of angle 4, and the measure of angle 6. Homework that you guys picked up on your way in the door today is due on Thursday. I will see you guys tomorrow. Have a great one, everybody. Don't forget to turn your homework in if you didn't already.